Hi and welcome to this video where we'll go into the Python fundamentals part 2. And in this part we'll go into error handling. So there are different types of errors that you should know about. And then we'll come into functions, which will make your code more dry. Don't repeat yourself. So that means that you can reuse parts of your code. If you feel like you need to use them several times, then put them into functions. And then we'll also go into matplotlib for drawing graphs and plotting, followed by NumPy for working with arrays. And NumPy is really good for speeding up things in Python. And then we have file handling and datetime. So this is what we'll cover in this lecture. So moving on to the Visual Studio Code and Jupyter Notebook, we have here. So I have a virtual environment like before. So in that one, I have already installed IPyKernel from the last lecture. And we can now see that we have here Python Fundamentals Part 2 and error handling. And in error handling, we have syntax errors, we have runtime errors, which are exceptions, and we have semantic errors that are logical errors. So starting with the first one, we create a new markdown here. And we have syntax error. So syntax errors, it's quite simple error that we can find. So for example, I write print, linear regression is a supervised learning algorithm. So this is a syntax error, as we can see here. Why? Because there's a syntax misspelling here. Actually, it's print that we want. We don't want print, right? We don't, Python don't understand what print is. That's why it says it's not defined. And you can see here there's a name error, and what it says here is the call. This is the traceback, which you should read whenever you get an error. So it says that in line 1, this is where the error occur, and the error is a name error, and it says name print is not defined. Yes, because we didn't define it. So it's a syntax error. So this one is easy to catch. You can catch it. The editor catches it so that you can see it. And also there's, if we're moving on, we have runtime errors. So for runtime errors, it's, for example, like this. We have numbers equals to range of 5, and we do a list of this. List of numbers. So if I run out numbers, we see we have 0, 1, 2, 3, 4, 4. And if we, for example, we want to pick the 5th element, maybe we want to run it like this, and we can see there's an error here. And this error occurs whenever we run it. When we run it, it finds that, okay, the numbers, it didn't have a 5th index, right? So there's an error there. So this is index error. And then we have, let's see, I'll make it into a markdown cell. And in order for me to make it into a markdown cell, I do escape M. So if I double click it, and I can change, I write Command B or Control B if you're in Windows to make it bold. So now I will have logical error. And logical errors are a little bit harder to find. And now we see that this is markdown. So I want to change it. I click escape and Y. So it becomes Python. Okay, and now for logical error, let's do like this. Import NumPy as NP. First, if I run this one, there's an error, no module named NumPy. So what should I do? I need to install it. So I've activated my virtual environment. So I do uv pip install NumPy. And you can see how fast it is. It's done. So if I run this one again, we can see there's no error. Good. And we get the radius of 5, and we do area circle equals to np.py times radius. And we do print. We do an f string here. And what can we do? We can do area circle equals point to f, for example. Okay. Yeah, area circle. Perfect. No error. Or when you spot it, this is actually the formula for circumference. So it's the formula for circumference and not for the area. So for the area is pi times radius squared, right? So this is a little bit harder to find out, and logical errors can be much harder, not that obvious like this one. And it could lead to subtle bugs, and which will be hard to understand and hard to debug. So logical errors really hard to find and debug. So let's move on. I'll change this one to markdown cell, and I will have try except now. Oh, misspelling, except like this. And let's run like this. So try age equals loads of input. Enter your age. If not 0 equals age 125. Or we can start with this. Actually, I will remove the try. I will just do like this. Input your age, and then I will type out age. So I run this one. -5. Yeah, that was a perfect age, apparently. I copy this one and run this again. 5. Yes, that's perfect. That's correct. Okay, run this again. 12,734. Yeah, okay, that's valid also, apparently. So what do we want to do? We want to try to stop this from happening. So in order for us to stop this, we can raise an exception. So we could throw an exception or raise an error in Python. So what we can do is like this. I copy this again, and we do if not 0, if not age larger equals 0, less than equal 125, and then we do raise value error, right? And we says that the age must be between 0 and 125, like this. And then afterwards, I want to print out how old you are. So you are f-string, age, years old, like this. And here there's like this. So if I run this one, 34, yeah, no problems. You're 24 years old. I copy this one and I run again. Now I will take 126. Okay, value error. Age must be between 0 and 125. Why is it value error? Because I raised a value error, right? So if this is not true, so if this condition is true, we will raise a value error. And when we raise a value error, the program will crash, right? And in order for the program not to crash, we need to try some code that is dangerous. For example, here, raising a value error. And also this age, where we're making an input into a float, where input is a string. So if it's just a string character, then if it's a string character that is not a number, then it will give an error, right? And we want to catch this error in order for the program not to crash. So I copy this one and I run it here. And now let's do like this. We do try and we do accept. And what do we want to accept? We want to accept value error as error. And then I want to print out the error. So if I run this one, 3, 2, 4, age must be between 0 and 125. That's good. I copy this one again. So you shouldn't just copy with him, or you could copy with me, but you could also create the whole code at once. So that's up to you how you want to decide to do it. I copy paste to show the train of thought, basically like each steps I want to show them and why we're doing things that we're doing. So I copy this one. And now what we want to do is that for the user to be able to try again after they have failed. So while true, so if I do while true like this, then they get to try a lot of times. 53, they try again. 423, and they try again, right? However, there's a problem here. The problem is that I will interrupt this and restart, because it's an endless loop here. So this is an infinite loop. So I need to interrupt this one. Yes, restart it. And escape to cancel this one. Great. So this one will run forever. So we want to break it whenever it is finished. So here I want to break out of the loop if in case we manage to fulfill. This is dangerous code, right? These two lines 3 and 4. If they succeed, then, or line 3 and 5 actually, these 3 to 4, 5, these are the dangerous part, could be generating an error. And if they are passed, that means that we didn't generate an error, and then we managed to print the age, and then we can break out of this infinite loop, right? So I run this one. Okay, I give some big number, failed. Yes, the age must be between 0 and 125. If I take some characters here, yes, could not convert string to float. Okay, good. So 25. Yes, you're 25 years old. So then the program stops. Good. So now you can see that this works, and you have seen some error handling now. So try accept this way to handle errors so that the program don't crash, so you can move on. Moving on to functions now, we can create some reusable code. So here, def squarer. So def is for define. We're defining the function. The squarer of x, like this, return x squared. So then I can just do squarer of 3, and I will get 9. Copy this one. And the squarer of 5, I get 25. Squarer of minus 3, I'll get 9. Perfect. And let's do, for example, I can use this function in a list comprehension for squares. For example, I can do it like this. Squarer of I for x in range 10. So then I get squared for each of the values, right? So I use this function. I put in the value for x in this function. So let's continue now. We could, for example, we can do functions for a lot of things. For example, def smallest. I could have number 1, number 2. So let's see, number 2, like this. So we have 2 parameters now. So parameter 1 is number 1 and number 2. So I'm talking about parameters when I'm defining the function. However, when I'm using the function, I'm talking about arguments. So there's a slight difference there. When you're using it, you're referring to it as arguments. When you're defining it, you're referring it to parameters. Let's do like this. If number 1 larger than number 2, return number 2. So then we get the smallest of these two. Else return number 1. And actually I don't need to do else here, because if this one does not, if this goes through, then we'll return the value. So we'll jump out of the function, right? Jump out of the scope. So line 4 won't run at all. However, if this is not true, then we'll jump over line 3, come into line 4. So we'll return the number 1, which is smallest. So using this one, we could do smallest of 7, 1, for example, and we get 1. So we could do smallest of 7, 7, and we get 7. Great. We'll move on to something called, this is quite cool, default value, like this. So def draw ASCII pattern. I'm showing different types of functions. Number rows equals to 5. So for I in range 1, number rows plus 1, print. Okay, so what am I doing? I'm doing a range from 1 to number of rows plus 1. And then I will do I times x plus number rows minus I times O. Okay, so this may take some time to figure out how to make this, but what I'm looking for is making a tree. So this is the pattern I want. So for example, I could do draw ASCII pattern, and I'll get a tree of 5 rows. I'll get a tree of 5 rows. I could actually do like that. I can zoom in a little bit. Sorry for that I didn't do it before. But you can see here in 5 rows here, because we have the default value of 5. And the 5, we can see that we have, then we do 1 to 6 in the for loop. So I will have values from 1 to 6. And then we have I is starting from 1, right? So 1 times x. So we get 1x plus number of rows minus I. So we have 5 minus 1. Then we have 4 times O. So we get 4 O's, etc. And then I increases. Then we get 2x and 3 O's. 3x and 2 O's, right? So I will copy this draw ASCII pattern and run it with 3. And we can see that we get 3 rows instead. And if I do one more time and I do it 9, for example, then we get 9 rows. So now we can see that we're reusing this function, right? With different types of arguments, but we have a default value. So the default value is 5. So if we don't put in anything, we don't put in an argument, then we get 5. But if we put in 3, then 3 will replace, so number of rows will be equal to 3 and not 5. Okay, so this was interesting. We can have, there's more interesting things with functions. We have arbitrary arguments. And this is a little bit hard for people to understand from other languages that are not in Python, but this is really useful. Arbitrary arguments. Let's see. The formatting is a little bit weird, so I need to do backslash of this one, like this. So star args, that's arbitrary arguments. So an example here, def my mean. So I will have an average, basically. So I will have star args. So this means that the user can put in as many arguments as he or she wants. So what we can do with this, we do sum underscore equals 0. I use underscore because I don't want to override the Python's default. They have a built-in sum function, which we can override if we write without underscore. So for arg in args, sum underscore plus equal to arg. So sum starts with 0. So sum underscore is just adding the argument, right? Adding each value that we get. So then we return sum underscore divided by length of args. And what do we get? I do my mean of 1, 2, 3, 4, and I get 2.5. And that's correct because 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, divided by 4 is 2.5. Okay, so how does this work? We get in 4 values here. So we get star args. So let's dive into what we have here. So what is args? So print args. What do we have? Okay, it's a tuple. There's a tuple of 4 values. So if it's a tuple of 4 values, we can loop over a tuple. We can iterate over a tuple because a tuple is an iterable. Right? So we iterate over the tuple. We can get the length of the tuple. So that's precisely what we've done. So now we've used this star args so that we can get several arguments in. So I could put in another type of arguments. I could put in 3, and that works as well. So star args really useful. We have something else called keyword arguments. Let's see. Keyword arguments. Star quarks. I'll do backslash here, backslash to escape the star because we have so many stars here. Otherwise, they don't know where it stops because star in Markdown makes bold. So now let's do like this. So we can do import numpy as np, and I'll change this to Python. Import numpy as np. Okay, it has some squiggy line here. Import numpy could not be resolved, but it doesn't matter. It works. So it just is the editor with the type, not the type, is editor and an IntelliSense that sometimes not work as expected, but it doesn't matter. So let's do like this. We will simulate some dices. So def simulate dices, and we'll have throws equals 1 and dices equals 2. And then I will print np.random.randint 1,7, throws, dices. So this is just the syntax for generating random numbers with 2, so throws, dices shape. So for example, I will do this, simulate dices. If I just run this one, we'll see what we'll get. We'll get 3,5 because we have 1 throw and we have 2 dices, right? So this is just how this numpy random randint works when you put in the shape here. And if I copy this one and I run it with throws equals 4, you can see we have 4 throws here. And if I do throws equals to 4 and dices equal to 3, we see we have 3 dices and 4 throws. And I will copy this again. And now I will do, so I've used keyword arguments here. So this is keyword argument. This is keyword arguments. I will use positional arguments now. So positional arguments, then I don't use the keyword. Instead, I will just place it in the order that the parameters are. So if I do 4,3, I get similar results as before. So this means 4 in throws and 3 in dices. However, I could do like this. I could do dices equals 4 and throws equals 3. So that will work as well. So now I'm using the keyword arguments. So then the order doesn't matter. But first you have to have positional arguments. Or if you have positional arguments, you have to place them first and then followed by keyword arguments. But now we don't have positional arguments. So if I run this one, it will work, but we'll have 3 in throws and 4 dices, right? There's one more thing I want to show you with the keyword arguments. So we can copy this one and run here. And I will remove, remember that throws was the first one, right? So I will actually remove the throws. I'll remove the dices here. And we can, I'll remove the throws and we run this one and it works. How come? That is because throws is defaulted to 1, right? So we have throws equals 1. However, if we had throws without default value, then this wouldn't work. So now I will move on to unpacking arguments. So let's do markdown cell here. Unpack arguments. So in order for, so there's something really cool here. You can do like this, option lists, for example, lists equals to 2,3. So this is just a normal list. And we could have an options. We could have, we could do simulate dices with star option list. Actually, I want to remove the est here. If I run this one, it works. Cool. So this means that we can put in a list as an argument. So we put in a list and we do a star on this list. Then we'll unpack the list. And when unpacking it, it will give us, so unpacking it will give us 2 and 3. So 2 and 3 as the inputs to the, it becomes positional arguments. So 2 and 3 are positional arguments now. So we could also do like this. I will copy this one and run again. Now I will have options dict instead. Dict. And I will make this into a dictionary. And first key is dices, right? Dices equals 2 and throws equals 3. And I could do like star options dict. And let's see, it doesn't work because this syntax is wrong. If I want to write this, I need to use the dict syntax. And it works. So this is really good when you want to have default options for different reasons. So you want to put in different options to your functions. So you can unpack. So here we unpack a list. So we got positional arguments. Here we unpacked a dictionary. So we got keyword arguments. So this is super useful. I'll go into lambda functions. So lambda functions are anonymous functions. So they don't need to have, you don't need to give it into a variable, but you could do that. So cuber equals lambda x colon x to the power of 3. And then you could do cuber of 3, right? So this you give it into a variable. So you assign it to a variable. However, you don't need to do that. You could run it immediately. So we could do lambda x to the colon of power of 3. And then we could place in 3 here. Or actually, we could not do this, right? Let's see. Oh, skip this. We cannot do that. So we have cuber. So how does this work? Lambda x, so x is the input variable, and the input is the input parameter. So you put in 3 as an argument here. So 3 goes in here, and then we'll have 3 to the power of 3, which is 27. But what can you do with lambda functions, and why is it useful? That is because in Python, there's something called higher order functions. So you can have functions inside of a function, and you can you can send in a function as an argument into another function, right? So that means that you don't need to define a function before. You can use lambda directly. So for one example, I will copy from my lecture notes, student, and we want to sort these students. So sort we could do sorted of students, and if I sort them, what happens? It sorts on alphabetical order, so it doesn't know how it should sort it. However, if I do sorted of students, comma, I could take a key, and the key I want to place in is lambda student colon student of 1, and that means I will sort on the first element in each of these students. So a student is a tuple, right? So then for each of them, I take the first value or the first index, or index 1, and sort based on that one. So if I run this one, that it's sorted based on the scores. So this function sorted, it takes another function. So you can see key, it takes in another, it doesn't say here, but it takes in this lambda function so that it can sort based on it. So then I could do reverse equals true, for example, like this. And we sort it based on highest score. Okay, moving on in the next list here, next thing we will cover is matplotlib. So in order for us to use matplotlib, we need to install it. So uv pip install matplotlib like this. And then we could do import matplotlib.pyplot as plt. And we can do, for example, f equals lambda x 3 times x minus 2. One thing I do for auto formatting is we need to install an extension called Black Formatter. This one you need to install. So after you install it, you can run it using Shift-Alt-F. So for example, if I do this, Shift-Alt-F will help me auto-format it, right? So Black is really good auto-formatter for Python. So do install it and do Alt-Shift-F quite frequently in order to get the code formatted for you. Okay, that was a small note. Now I created a function, 3 times x minus 2. So as it's a linear function. So let's graph this one. So def, we can do, for example, plt.plot. We need to place in an x as well. So I can do x equals to tuple of range minus 5, 5. So then we plot x comma y, right? So f of x doesn't work because we cannot do f of the whole tuple. Instead, we need to do a list comprehension. So we can call this y equals to f of I for I in x. And then we put in y here instead. And we managed to plot it. So how does it work? We have x, we can run x here, so you can see that this is x, and you have y here, and you can see this is y, right? And so basically we do a list comprehension here, and we put in f of I, so we put in each value of x inside of this function, and then we plot it. And in the lecture note, I actually plotted another function as well. but I won't do that here. It's enough with one function. Or actually, I will plot it so that you can see more about the matplotlib and how it works. Actually, we will go into matplotlib more in detail later. So this, what I show now, is using matplotlib stateful syntax. However, there's another type of syntax called object-oriented OOP approach, which we will use later on. But for now, you can use this PLT syntax. So let's continue here. I'll create more functions. I'll create def g of x, return x squared minus 2. And here I will also create, let me move them upward. So I can mark them and do alt up button, so to move them up, or option up. So now I have g. I'll put them together with the f here. This is to show you that this is similar. Here one with lambda function and here one with normal definition, right? So here we have x is the same and we have y here. I'll create the y2. I will actually give it more spaces. y2 equals to g of I for I in x. And then let's plot another one. So plt.plot x comma y2, and you can see that this is my second graph. And we could continue here, plt.title, and give it a title. So plotting two functions. And basically a plotting, what does it mean? It means that we have one value for x and a corresponding value for y. We actually plot two functions here. So this x here and corresponding to its y, this x corresponding to its y, etc. So you can see that since we only have integer values, we get very pointy lines, right? So you can see that it's not very smooth, but we'll fix it later. So we could continue here, making a plt.x label, x, we copy it, y, and for copying quickly you do shift option down button. So shift option down button again, and I have x, y, and I will have a legend as well, plt.legend, and we can do, I'll make something called latex so that we can get nicer printing here. That is for math, using math. So this dollar just means latex. LaTeX. And it doesn't work here because we need to have a list of two functions or two strings basically. So I will have here, I will do g of x equals to x squared minus 2. So using LaTeX, we get when we use when we have x squared, we get here in the superposition. So we get x squared up here. Otherwise, you will see an angle here too. So now we have both of our functions, and we have created a y, actually x label and y label like this. So we get an x and a y here. So we get the labels, and we have a title. So basically, this is how you create graphs in Matplotlib. And Matplotlib is super useful. You will use it a lot. And now we'll move on to, we'll make this a little bit smoother. We put in some NumPy for plotting. And using NumPy, let's do like this. We have imported NumPy before, so we can do x equals to np.linspace minus np.py, for example, comma np.py. So then, what is x? If we run it, we see that it's actually 50 values from minus pi to pi. So it's evenly spaced between these two values. So then we can define f equals to lambda x squared plus 1. G equals to lambda x np.sin of x plus 5. So we have f and g now. Now we'll use an OOP approach. So before we used PLT and its MATLAB syntax. It's MATLAB is another language which Matplotlib has taken a lot of inspiration from. So we have x.plot, or actually we need to do like this, x comma fig equals plt.axis comma plt.figure. So this is actually, we create a tuple here, and we do a tuple unpacking here. So x becomes plt.axis and fig becomes plt.figure. So we can do x.plot. So x is an object now. It has a method called plot. And what it can do is similar to plt.plot. So you can do x f of x. And then you run it, you get here a sine function or this f of x, and you can see it's very smooth because we have a lot of values here for x and for y now. And we can do here label equals to, I'll do latex again, f of x equal to x squared plus 1. And the label doesn't show anything, but when you do x.legend, we will get, let's see, x.legend, we should get, yeah, exactly, here's the legend, and the lib chooses where to put it. You can actually place it another place if you want. There's options for doing that. x.plot x comma g of x comma label equals to g of x equals to backslash sin of x. So this is just this is latex syntax. You don't need to understand it fully actually. Let's see, g of x equal, yeah, we need to have a dollar here as well. So why do I need to have it works? The reason why I need to have 2 backslashes is 1 backslash is for latex. So if I remove 1 backslash, what happens? Yeah, it works. Sorry, my mistake. Okay, so we can see here we have f of x and g of x, and we get them plotted, and we can do. And okay, so what's the difference between using X and PLT approach? Using the PLT approach, we need to write a lot of things, while in the X approach, we could add in a lot of methods. So for example, I can add in several things at the same time using set. So x.set, we can do title equals to graphs, x label equals to x, y label equals to y. You can see instead of writing plt.xlabel, plt.ylabel, plt.title, we can use the set method here using the OOP approach. Okay, and in my lecture note, I have more on NumPy. Then we dive more deeply into NumPy and how it works. But now I'm actually satisfied with using NumPy for this simple example here. There's a lot of functions in NumPy that is very useful. So let's move on to something called file handling. So file handling. And in order to do this, we'll create a folder here called data. And inside of this folder, I will place in a file, which you can find in the lecture notes. In the lecture folder, you can find the file. So I placed in the file, so you can see this mltext raw.txt. So in order for us to work with this one, we need to open it up. So let's do like this. In order to open a file, usually you can use open, but then when you use open, you need to use close also. However, in Python, there's something called a context manager, which you can read file using a with statement. And when it's finished, when you're outside of the with statement, it will automatically close all the resources that has been opened. So this is really useful. So it will close your file. So always do like this. With open, and we need to have the path. We need to have the path to this file. So I write data /ml underscore text underscore raw.txt. So this is the file. It's a relative. In Jupyter Notebook, it's a little bit different from in Python script, but we will work with Jupyter Notebook at first. So you find exactly where it is through data. So they are siblings. So you go into data using data, writing data like this, and then go into ml text. So you have /ml text raw.txt. And then you choose how you want to, what the type you want to do. If you want to read or write, I would choose read, so R as file. So this means you have a handle to this. So you have file as this variable. So now I can use raw text equals file.read. And if I print raw text, you can see how it looks like. Okay, so this text is a little bit messy. You can see the original text. It is really messy. Okay, but we have to fix this. So now we're outside of the context manager. So we have raw text as variable, but the file has been closed. So let's remove all these extra spaces. So I will do import re. Re is regular expression in Python. And regular expression, you can have, you put in special types of pattern in order to match different things. So for example, we can do like this. Re.sub is a substitution. So we want to substitute everything that matches this pattern. S plus is space, one or more spaces. So it matches one or more spaces. I want to replace this with just one space, right? And I will place in raw text, and we can see what we get. Okay, we saw that a lot of spaces became one space. That is perfect. Okay, so we call this text fixed spacing equals to this. And then we do text list equals to a list now. And what I want to do is I want to split this text. So now this is working with strings, right? So we want to split this text. So I do for text in text fixed spacing dot split, and I want to split on a dot because that is where a new sentence starts. So if I run this, I need to write text here, and we can write text list, and these are all the sentences we have. So we splitted on the sentences. And I would like to capitalize this. So text.capitalize. What will happen? Only the first character becomes capitalized. Everything else becomes lowercase. Great. So this is text list. And I can use this text list to join it. So then I can do like this. A string. I want to join a dot and \n to get a new line character. Dot join this text list. So then we get \n here for new line characters. And I can call this clean text. Okay, it doesn't look so clean. You have to print it. So if you print it, cleaned text, or clean I call it, so you can see how it looks like. Oh, better, much better. Let's do like this. Now I'm happy with this text, so I will place it back into data here. So I'll do with open data /ml text cleaned .txt, comma write, W for write, as file, and I do file.write cleaned, like this. And when I run it, you can see there's ML text cleaned, and this is the clean text. Great. Good job following this far. So now we have file handling, and we have one more thing to go through in this section, in this lecture, and it's datetime. So datetime. So datetime is the library for working with dates in Python. So from datetime, import datetime. So if I want to have now, I will do datetime.now, and we can see, let's see, I will write out now, we can see what we get. Get datetime, okay, this is 25th, 15, 9, 59, and how many seconds? Milliseconds, I think, right? 59 is seconds, and here are milliseconds. So if I run it a few times, you can see it changes a lot. And you see the seconds are going up 1 per second, right? So this is basically, now we have a datetime. From this datetime object, we could do like now dot different methods. So what type of methods do we have? Now dot, for example, we can do dot date, and we can see this is the date of today. We could do now dot string f time. So this one is if we want to change the formatting, and I want to change it to A, and we can see it's Wednesday. So there's in the documentation, you can see there's a link to extra resource where you will get all these different, there's tables for how you convert to different things using different names. So, or using different characters. This gives us the day, and if we do copy this one, and you change it to W, for example, you get the week. So week 52. And if you change it to, let's see, if you change it to Y, then you get the year. So there's different date formatting that is good to know, but you should look it up. Similar to regular expression, there's a regex formatting that you should look up as well. So we can do some date calculations. So for example, we can do new year, or we can do graduation date equals to, let's see, for example, 5/6/2025, and we can calculate now. Graduation date equals to datetime dot string p time. So this is from datetime, you can use string p time in order to change it to a string. So I can do here graduation date, comma. Then we can choose how it should look like. So I can do D for day, M for month, and I can do dash big Y for year. And then you can see it looks like this. So this means that, okay, so what does it mean? We have graduation date in this formatting. So in this formatting, then we need to specify how the formatting is. It's day, month, and year. So then we can make it into a datetime object. And from this datetime object, we could change it back to string, right? With string ftime. So remaining time, we could do like now. We could do graduation date minus now. And we get how many days left for graduation. We could do remaining time equals this. And then we could do remaining time of, we could print remaining time. And you can see when this is the wrapper, it looks like this, but when we print it, we see there's another string. So then the string is defined differently for dates. So you can see here is a time delta. So we have 161 days and how many hours, minutes and seconds. And we could, if we would, we could do remaining time dot days 161, and we could divide it by 365. And we can get number of years. So this is in years then. Okay, great. And this was everything that I wanted to show you in this lecture. So thank you. See you in the next lecture. Bye.